Hello everyone. Today we are going to discuss a very interesting topic related to the potential gradient, chapter 2, electric potential and capacitance. So first we will start the definition of electric potential. या electric potential क्या होता है? The amount of work done to bring a charge from infinity to that particular point without acceleration is called electric potential. Today we are discussing the potential gradient. So how the electric potential related to this today term and the electric field, today we will concentrate over these points. So we will start our topic as a potential gradient. It is the rate of change of potential. It is the rate of change of potential with respect to the distance. With respect to the distance. One thing you have to remember here, that distance, the rate of change of distance must be in the direction of electric field. So it is going towards the electric field or away from the electric field, then gradient can only be measured. So direction is necessary of the electric field is called potential gradient. Now mathematically what it will be? मैथमेटिकली हम लिख सकते हैं पोटेंशियल ग्रेडियंट विल बी इक्वल टू द चेंज इन पोटेंशियल विथ चेंज इन डायरेक्शन, change in distance. So it is the ratio of these two quantities in the direction of electric field is called potential gradient. Now we will concentrate over the relation between electric field and electric potential. Now relation between electric field with, either we can write the potential gradient as well as we can write the potential difference. The both will be same as it is here. The relation between electric potential with potential gradient. Potential gradient. Potential gradient. So how we will deduce the relation? This we will see it. First of all, we try to understand the condition where we are calculating it. So suppose we are making an origin charge, it is the positive one. From that charge at distance r, we are assuming a point A, which is you can say that from A to point this one, like this. And another charge is called test charge. Another charge is test charge is coming towards this point from B. The distance between them is traveled dr. So dr will be assumed when it will be till here. So dr here, the distance will be covered due to the applied external force through some agent. So that charge will only move by the applying of external force. Why we are applying the external force? Because due to this origin charge, there is some electric field apply over this test charge. That electric field will oppose the motion of that charge which is coming towards the origin charge. But due to that applied external force, there is a displacement, and that displacement is stored in terms of work done in this. So first of all, we will calculate the force, the external force over test charge. So what it will be? It will be F is equal to against the electric field over the test charge. That will be a force. Due to that force, there is a small amount of displacement is done. That small amount of displacement is from this total quantity. So the remaining distance is left out, this one, from A to O. So remaining distance is this one. So the work done is dW due to that applied external force over the small displacement. I am taking a displacement negative because the total distance, or you can say that we are working work against the electric field. So displacement is negative, or you can say that towards the reducing direction of distance. So that is our total work done. We know the value of F, we will put it here. So dW is equal to Q naught E dr, and negative will be here. Said that Q naught will be divide dW, and we got minus E dr. Said that dW upon Q naught is, according to the definition of potential difference, will be the potential difference at final stage minus initial stage is equal to minus E dr, because we know that VA minus VB is equal to WAB divided by Q. We have discussed it earlier. So we are replacing this value with this one. So that VAVB is basically is what? Delta V. So WAB is potential work done over the test charge. So that will be the electric potential difference, or you can say that difference in the 2-point potential B to A will be minus E dr. So by doing all these things, we can easily get the value of E minus dV upon dr. That is what our relation we are trying to find out, relation between electric field with potential gradient. So that is electric field, and that all about the potential gradient we have discussed earlier. So with the help of this negative one, it is coming. So there is a two important conclusions come out from this. What are those conclusions? Let's discuss them. So see that electric field is, what is that? Electric field is directly proportional, or you can say that electric field is related to the potential gradient in terms of negative. The first relation is that electric field is negatively related to potential gradient. Potential gradient, what does it mean? It's mean that if we see that, or in the line of origin of this one, O to this A and B, all these lines are in same, you can say that in the via the center of these two charges, it will be give a relation that the work done, or you can say that electric potential will decrease if potential is increased. So in that case we can say that if we go this way, the electric field is decreased and the potential of this one is negatively. So steepest, if the potential is the steepest, then electric field is having the relation with this one. So this relation is also there. And another relation is that, second relation is showing that negative, in spite of this negative relation, second relation is showing that E is inversely proportional with distance also. We have earlier discussed that the electric field is negatively proportional to this. And here also at that particular point A, wherever we go around this charge having this distance or that particular fixed distance from that origin charge, electric field remains constant. So in this case we can understand this way, that if the charge is this one and we are having the point A with the r distance, so entirely having the same distance around it, the potential will be same around it. So this imaginary circle is called equipotential circle or equipotential surface around that charge here. So second point comes in this relation is that electric potential is what? The rate of change of electric field is what? Electric field is related to the rate of change in distance with electric potential. So these are the two conclusions which comes with the help of this one. Now on the basis of these conclusions we will do another thing, is that it may be possible that it have the three components in terms of, you can say that three vector components in there. First of all, what we can do, if that electric field have x axis, y axis and z axis, so what it will be? It will be E over the x is equal to what? dV over dx, and Ey is equal to dV over dy, and similarly with dz also, so dV will be divided by dz. So equivalent capacitance will be Ex plus Ey plus Ez. So it will be dV upon dx plus dV upon dy, dV upon dy and dV upon dz. Okay, so my negative remain as it is here also. So these are the terms which is related to the electric field, that net electric field in this. Second is what, that these two quantities, electric field and the displacement, is basically a vector form, in the vector form. So we can write it like this: E is equal to minus dV upon dr, and another dV is equal to minus E dot dr also. So that is our relation. If the two plates of capacitor having the small distance d gap between them, plate 1 and plate 2, we can also write the electric field between them is what? That is dV upon d. So that will be this one also in case of capacitor. So these are the three conclusions. And another, if we go to the direction or go to the dimension, or you can say that go to the SI unit of this one, the volt per meter. So it remain as it is. So these are our topic related to potential gradient, relation between electric potential and electric field. There is some different type of formula in the different cases we use. The important conclusion is made over the basis of this formula is this one. So this is all about the potential gradient. Potential gradient is very you can say that useful term for upcoming numericals and upcoming topics. So it will be hidden in the questions. Sometimes we identify with the help of this units as well as with the help of this formula. So it is up to you how much you practice over this topic, and it will be definitely help you in upcoming examination. Thank you very much.